All right, ladies and gentlemen, today's topic is proportional relationships. This is the first in a new unit, Unit 4. This unit is all about ratios, proportions, and how we use proportions in the real world. So our objective for today is I understand what a proportional relationship is, and I know how proportions are, whoopsie, that's supposed to say used in several math situations. Please make sure you are putting the date and the page number. A lot of people lost points on this on their notebook check. If your next page number is not 54, label it 54 anyway. If you're starting a brand new notebook, label it page 54. Also, make sure the date you put on is the date that I have here. This is the date that the video was assigned. So don't put the date that you watched the video, put the date that the video is assigned. All right, so after you get that objective written down, you have your page numbered properly. Go ahead. You might need to pause it if you weren't done writing that yet. This is going to be on that same page. The concepts of proportions are used in the following math topics. I want you to write that down. And I get the question constantly, when am I going to use this in real life? Well, proportions are used very frequently in real life. I'm going to show you just a couple examples, and yeah, write these down. Scale drawings. We're going to get into doing some scale drawings, like taking something, maybe a house, and making a blueprint of it. It's used by architects and construction workers. Construction workers have to be able to look at a blueprint and then build the house based on that design. So they have to understand the scale of the blueprint. It's also used in percents. Our next unit after this is going to be percents. And this is probably one of the most common things that that is used in the real world. It's used by businesses. It's used by banks. It's when you tip a server, because you have to calculate, for example, what 20% of the bill is, and then you tip the server that. It's also used in similar figures. So I have one triangle, and then I have another triangle, and they are similar, which means that there is a proportional relationship that exists between them. It's used in linear functions, and 8th grade, when you guys get there next year, linear functions is a huge topic in 8th grade. And it is when you have things like this, f of x equals 3x plus 7. We're going to be working a little bit with things like this year. But businesses, finance people, marketing, science, engineers, pretty much every career is going to use a linear function at some point or another. Manufacturing, design, all of those. So take a minute to write these down. One other thing, I noticed in some of your notebooks that your handwriting was less than spectacular, and I know that's because you're just trying to rush to get the video done. Please actually put some care into your notebook. I'm going to be taking a neatness grade on the next notebook check, so that can earn you some points or lose points for you. Once you're done writing all of that down, we're going to go to the next page of our notebook. This should be page 55. The date, once again, is November 4th. And what's going to be on this page is figuring out if something is proportional. So I have over here on the side a way you can tell if two fractions or two ratios are proportional. We talked about ratios in class today. Ratios is, for example, if I have 6 cats and 3 dogs, the ratio of cats to dogs is 6 to 3. It can also be written as 6 over 3. So we have a couple fractions over here. And if your fractions, the two fractions you have, simplify to be the same, they are proportional. Now, in order to do this, you have to be able to simplify fractions. So a quick review of how to simplify fractions. If you have your fraction here, you look at, is there any number that both your numerator and your denominator can be divided by? And in this case, both of them can be divided by 3. So I'll take my numerator, divide it by 3, that gives me 1. Take my denominator, divide it by 3, and that gets me 4. You know how I'm making you guys do extra math all the time? Those kind of basic math facts, 12 divided by 3 equals 4, you just have to be able to do them. You have to know them. So that's why extra math is so important for you. So if you look, we have our first fraction was 1/4, and our second fraction simplifies to 1/4. So 1/4 and 3/12 are proportional. There is a proportional relationship that exists there. You can also tell another method is if you have two fractions, the cross products. I think you've done cross products before in previous years, but that's essentially you take the numerator of one, multiply it by the denominator of another, and that would equal 12. And then the denominator of the first one times the numerator of the second one would also equal 12. If your cross products are equal, the fractions are proportional. So there's two different ways you can check to see if a fraction is proportional. Make sure you're writing all this down, guys. Let's take a look at this fraction. We have 2 over 6 and 6 over 10. I'm going to show you both ways. The first way is simplifying the fractions. So I have 2 over 6 here. Both of those, the numerator and the denominator, can be divided by 2. Hang on. They can be divided by 2, and that would give us the new fraction. 2 divided by 2 is 1, 6 divided by 2 is 3. So this first fraction simplifies to 1 over 3. The second one, both the top and the bottom can be divided by 2, and that would give me 3 over 5. Because these fractions are not equal, they're not proportional to each other. If we want to use the other method of the cross products, you would do 6 times 6 is 36, and 2 times 10 is 20. These numbers are not equal, therefore it is not proportional. Okay? Pretty basic stuff in this video, guys, not too tricky. So here's a few more examples. Remember that ratios can be written in several different ways. You can use the colon to represent a ratio. The easiest way to deal with ratios and proportions is to turn them all into fractions, however. But don't get freaked out when you see something like this. 3 to 4 is the same as 3 over 4, and 5 to 10 is the same as 5 over 10. I'm going to use cross products on this one. 3 times 10 is 30. 4 times 5 is 20, so they are not proportional. Include these examples, include these examples on that same page. You should still be on page 55. You should be writing all these examples down. Second example is 5/25 and 2/10. So I'll write it this way. And I'm going to try simplifying on this one. So I'm going to take my first fraction, 5 and 25. They can both be divided by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So my first fraction simplifies to be 1/5. And then my second fraction, I have 2 over 10. They can both be divided by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. So these are proportional because those two fractions simplify to both equal 1/5. And a final one. This one is a little bit tricky. Notice that I have a decimal number in one of my fractions, and you are going to be seeing more of those as time goes on. I'm going to use my cross product to figure out this one. 6 times 3 is going to be 18, and then I have to do 1.5 times 12. I'll go ahead and use lattice because I think that's what you guys are most familiar with. 1.5 and 12. Draw my little lines. 5 times 1 is 5. Oop, I wrote really small, didn't I? 5 times 2 is 10. 1 times 1 is 1. And 1 times 2 is 2. If I go diagonal, I have 0.180, but I have to remember that I have this decimal point. So when we are multiplying decimals, we slide that decimal point down, and our hidden decimal in 12 is after the 2. So I'm going to slide that over, slide that down. Where they meet right here is going to be where my decimal point is. So it would be 18 is 1.5 times 12. Notice that these, Notice that these two numbers are equal, therefore it is proportional for this third example as well. Okay? So there's the basics of proportions. Your reflection question is I want you to find out if these two ratios are proportional, and most importantly, I want you to tell me why. If you just submit a yes or a no, you will not get credit for this reflection. All right, guys, have a good night. I will see you next time. Bye-bye. Bye.